Hello everybody, Tasfa here. Welcome back to this program. Well done if you come to this level. This is our last section in our 70 or more videos, which we run through all areas of Java programming. That specifically, let's say, very good introduction for a beginner. Today we are going to see the concept and examples of OOP, Object-Oriented Programming. This is our final section. So I am sure if you've gone through all the areas we covered so far, if you have downloaded and exercised with your own example and with your own coding, I'm sure you've been on the upward side, that you have been doing well in Java programming. This last section is more than beginners area that will help you to introduce to intermediate or even high level programming in Java. So we're gonna see together, this is where the concept of programming resides, where you learn why programming use this concept. So object-oriented programming, actually, as it refers to, is referring to an object, any object in real world. So when we say object, it normally refers to something that doesn't have life, like tables, chairs, and so on. But in Java, everything can be an object. So object in the world, in real world, is the classification of things where we can name anything as object. That tree, that stone, that table, and so on and so on. In Java, though, because this is a code free of objects, I mean physical objects, material objects, it is a code, isn't it? It is a software. So we, in Java programming or in other software development, it is the representation of this object by name and by behavior into the Java programming. So to do that, we have some building blocks for those. One of these is object. So let's see let's run through the slide so we can see, we can talk more. So this is a shift in programming. So that's why it's a paradigm. It's an area, it's a conceptual area where the programming uses some kind of structured thoughts. Structured thoughts comes as an object, based on an object, and also classes. I will talk about classes very soon. So these programs use the idea of real-world classifications, groupings in Java. For example, the idea of class, if you remember your high school biology, we have classes in animal kingdom, in plant kingdom, yeah? So this classification is also, that concept of classification is used in here as well, so that the idea can be organized, can be systematized through this object and the classes. Here, class in Java is just an idea, a blueprint of something is real, or something in real world, or something not in real world. Actually, anything that can be classified as class. So here it is. It is an abstract and a blueprint. So it is just to refer to a group of animals. For example, we can use human as a class or cat as a class by itself, either animals as one class and the others as subclasses. But then we can take one of subclass, make them as class. For example, dog as a big class, and then breeds as subclasses. Or you can take bird as class, even though you can put them as a subclass under animals, isn't it? But we can make them a superclass as well. There's no limit in here. So bird as a class, and then we can put parrots and other birds as a subclass, as a subdivisions of that subclass. So it is a blueprint. It's an idea. No, it's not as something that we see in the real world, but we can conceptualize and use that idea in programming. And classes represent broad categories that share attributes that just I said. If we take animals, all animals share some kind of behavior. They all reproduce, they all breathe, they all walk, they all have sounds and so on. And if you come down to dogs as a class, now that dog represent some kind of common behavior, as they are canine, they are dog family, they can reproduce and so on. So we use a broad category to represent a class. So in programming though, then in software development, classes contain functions, methods. We can add them. Like in real class, dogs were all, for example, if we take mammals as a class, they have a broad category attribute or behaviors, like they all feed their youngest with milk, they all give birth to a live child, and so on. And this reproducing can be defined as a method, a function when it comes to code. So the class is the category of objects that exists, and those objects have their own behavior, which we can actually create a method in them, and those methods actually do some kind of actions. For example, if we say they create voice, the meow, and so on. We will see this in an example in our next videos. Object-oriented programming is based on the idea of a class and objects in real world, but we change them into the idea, the blueprint, and then we develop those in object-oriented programming such as Java. That's why it is called object-oriented programming. So the class as a category of having broad attributes being as used as a class. I'm just giving you the animal classes, but we can have a lot of classes. For example, a class of student. All students will share some kind of broad category what makes them a student, and we can ignore that, and also we can bring to the business environment, like sales. All items to be sold have some attributes. They share some category of having price, having price increased, decreased, having a location or a shelf storage. These categories can be used as following up the business undertaking. So we can use those behaviors or attributes in method so that we can manipulate anything related to those activities. So let's more. So why object-oriented programming is good for programmers? So one is it makes modeling complex things. Like if we want to document all mammals or all animals, classification of all animals. For example, we have 5 classifications, core classes like mammal, bird, amphibian, reptiles, and what else? Fish. Yeah. If you want to document this, we have one big super class animals, and then in each subcategory we can put their behaviors, attributes in the methods, what they do, how do they act in those. So we can document like this. So we can model real world either business or research undertaking or any kind of thing that we think can be put an idea can be modeled. So this actually is helpful now very widely in artificial intelligence, for example, in predictive modeling, for example. So that's very, very useful. So it helps us to model, and also in doing that we reproduce. We can reuse it, we reproduce it as well. So it's also very useful in creating multiple of those, and in polymorphism we'll see what polymorphism means. Well, actually, if you have one class, okay, with one name, we can have one specific action. We can make that class do another specific action. So we multiply polymorphism. So polymorphic means many form. So we can have classes have different forms, and then have in those different forms applied to different methods, and then different output actually. So that will help. We'll see this in example as well. And also we can secure the information we store, because this is a era of cyber attacks, cyber problems. So through what is called encapsulation, we can cover up, we can protect, we can encapsulate some ideas, some information, sensitive information, into one kind of capsule, okay, one kind of a small batch of category that is protected through different access modifiers like private, we have seen in previous videos. So once we make it private, we can't reproduce. Reproducing those kind of information are not public anymore. It's not possible. It is hidden. So object-oriented programming can be useful for such kind of programming concepts. The building blocks of object-oriented programming, I'm just introducing to you. Okay, one is class. We already said this. Class can contain fields for attributes and methods for behaviors. So we have seen some of this class. We were doing actually not some, but we created lots and lots of classes, and we put some methods, some attributes, some behaviors, and we were printing those. So class is the most important concept in object-oriented programming, and it is one of the building blocks, very useful building blocks. The other one we saw is object. Object are instances of classes. When we say object are instances of classes, it is true, isn't it? In the real world, for example, let's bring back the concept that we have in biology. In animal kingdom, for example, the animal kingdom, if we consider that as a class, we can take mammal as an instance of animal kingdom, or come to the dog family, for example. If we consider dog as a class, I can take German Shepherd as an instance of the dog, isn't it? It's an example of a dog. So objects are instances of class in Java programming or in other programming as well. And it is an instance. We create an instance of class. We actually say initiate it, we create that object, and then we will have a different argument for that. Maybe it's a little bit, I will show you later on. For example, in first object, in first instance of object, we just want to print the name and the age. Okay, so it has two argument, name and age, and we can create another instance, but this time we can add another argument, name, age, and for example gender. Now this one has 3 arguments, the previous one 2 arguments, so we can't print for example gender in the first instance. We have to create another instance for that, or change that instance to include the gender. So we have now 2 instances of a class of let's say a dog or some class we created. So we will have different instances based on the number of argument, or what argument we will have. Also on the type of argument, we can create instance as well. So that's why we say object is an instance of a class. Okay, and obviously methods. So method is we have seen in Java inbuilt methods like mathematical methods, isn't it? Max, mean, absolute, square, and so on. These are methods. They do something. In other user defined methods, we can create our own method. For example, a method called sum. You can't find sum in Java libraries. You create sum is the variable x plus the variable y. It's an addition. So methods will do something. Or in other forms of, for example, classes, like the method, for example, or function called run. You can say, you can name anything, run, and then in that my dog run faster than other dog, and you can feed that information, or call another method on that, and then it will print out, it will do something. And more on that, there are lots of methods, inbuilt Java methods, window object methods, which you can call like action listeners and so on and so on. So these are the things we use with the object and with the class, and they are very useful. Without these methods, so it is not possible to get any output. Attributes are information that is stored. So if I say method is sum, the value that is stored in the sum is the attribute. So the information that is stored in this methods. So it is part of building blocks of method or objects, like variables, for example. It is one of those building blocks that we use in object-oriented programming. And these are the 4 principles that we're going to cover in this section. These 4 principles that we have in object-oriented programming are: one is inheritance. So inheritance, as the name implies, is inheriting some methods, some behaviors from the broader category. Let's say when we say animal kingdom, or let's make it class, animal class, what do they have in common? If all animals are similar in some way, we say they have some kind of inheritance. Let's say we say that dog is one class, or cat is one class, and all cat or all dogs have some kind of behavior that they share. That's how we inherit from the Java programming. If we in our code say Uh, cat is our class, and we have Tom the cat. So Tom the cat has a behavior of the class cat. So Tom has paws. Tom is fluffy. Tom, there are behavior that we can get from super class, which means the higher class. So in Java programming, in object-oriented programming, so in order to enable inheritance, we put behaviors that's common to every class member in the class object, in the upper class. For example, if you have a class cat, we put all those behaviors in class. But when instances of this class, the objects like Tommy, like another car, like Jappy, my cat, are created, we inherit those from the class cat. We will see this example in practice very soon in our next section. So inheritance is one thing, and without inheritance, actually, we don't have some concept of class as well. That's why class is there, and the class it tells us that every class instance of class, which is object, inherits from the class, from the class. The idea of superclass and subclass is a little bit early for this course, but I'm referring to the higher, the broader category in here. And the other one is encapsulation. So I touched about this earlier. Encapsulation is containing information in an object and exposing only selected information. So it is a way of filtering information, private versus public information. We encapsulate the information that is private, that we need to keep, like, the password, personal information, if it is not shareable. Even a class type, if they no sharing with others, we keep it encapsulated into a batch of code. So that is another principles in Java programming. Abstraction. Abstraction is another way to keep information secret, only exposing high-level public methods for accessing an object. So we make it abstract. When we make it abstract, actually we call it abstract class. Exactly, we say we use the keyword abstract for that. Once we make a class abstract, it's not accessible somewhere. We'll see this in an example as well. So that's another way of keeping information secret or categorizing information into public and private. The other one, which also we have seen, is a polymorphism. Polymorphism is, as the name implies, making it many forms. So a class, a method can be many. We can define it differently so that we can use it differently. Like for a method, for example, we can have different arguments, but we will have the same method name. Method can be different because of the argument they take. One argument, two argument, or string argument, or int argument. So then we have a polymorphic method or class. This is very useful because we don't have to define another method, another class, as many as we need them. We just call one, just call or refer to one, or create an object of that class, and then we use with a different method. So this is the concept of object-oriented programming, and in our next 4 or so videos, we're going to see examples of these 4 principles: abstraction, inheritance, encapsulation, and polymorphism. I hope you have a good understanding of object-oriented programming by now, and I will see you in the next video. Bye for now.